everyone. I'm going to introduce you to web wrapping tools. First is Beautiful Soup and the second one is Scrapy. So you may be familiar with pandas.read HTML. Under the hood, this method uses Scrapper like Beautiful Soup to parse table HTML table, read the content, and load it into a data frame and return that data frame. However, sometimes we may not need to read the entire table. We want to select certain part of the table, or sometimes we just want to select certain HTML element and read the content. At that time, we can use Beautiful Soup library. So to install Beautiful Soup, um, we use pip command, and we, along with installing Beautiful Soup, we also need to install a parser and a parser to parse the HTML, and the one is recommended to use is LXML because this is the fastest one, and sometimes it will not sometimes it will not skip your tag if it does not understand. And to use Beautiful Soup, the first thing we do is create a soup object using the Beautiful Soup constructor. It will receive an HTML document, an HTML string as its first parameter, or you can pass an open HTML file, and the second parameter is the name of the parser. And you can also use Prettify to read the content of the HTML document. So here we will examine this HTML document, and let's define some of the tag here. So we have the HTML tag, and then we have the head tag. The head tag help define the metadata, the data about the data. One of which is the title, and we have the body tag, define the body of the document, and inside of the body we also have the main tag, define the main content of the body, and you also see that there are hashtag h1, h2, or h3, h4. They are headings, and we have p tag defines the paragraph, and we have the input tag defines a text field to type, allow user to type something, and we have ul tag define an order list, and inside of that list we can list item using the li tag. And you can see that we have some attribute like class or id or name. So they all help identify the element. However, class identify a group of elements. For example, like 3, those li element belong to the same class, this group item. And id uniquely identify an element. For example, input, only input has the id, and no two element can have the same id. And name attribute used for form like input. And this is the how this picture shows that how this HTML document is rendered on the browser. So we have a heading, another heading, we have 2 paragraphs. We have an input text field, and we have a list of items. And and as you can see, and so next we let's take a look at how we going to read the content from the soup object. So here we already have the soup object um, that be able to parse our HTML, and we can access its tag element using the tag name, for example, soup.title, soup.h1, and we also can access the text using that text, only access the text inside the element, and we can also access, if you want to access the attribute, look at what attribute that the element possess. You can .attrs. Furthermore, this p tag has this attribute class and ID, so we can see that it belongs to class mb3 and red, and has its ID is p1. And but uh, as you notice that we have two paragraph element, but when we use soup.p, we only get one p. So there's another way to solve this. We can use find all. It will find all of the elements that match the condition. And also, like when you use find all, there are different ways that you can um, define the condition to filter out the elements. So it can receive the tag name as uh, the first approach. Secondly, you can pass in reg regex. For example, this it will just find elements that whose tag name contains the H and then a digit, which means that it only find the headings. And next, it also can receive a list of tags. For example, it will find all elements that p tag and heading tag, and it also can filter element against its attributes such as ID, name, href. For example, when you specify ID question, when we find all element whose ID is input 1, and you can also specify multiple attribute to filter against. And find all can also search an element using a function, so you can pass in a lambda expression that or a function reference that define how are you going to filter the condition. For example, in this case, the element that has this attribute data cell alignment will be included in the result list. And next, we have find all. Find all also can search using the class name of the element. So in this case, we will find all element that belongs to the class list group item. Next, we can also pass in two parameters. The first parameter is the tag name, and the second one is how you are going to filter out whether it is a lambda expression, a function, the attribute, the class name. Here we use the string, which means that it only get those elements that p tag and the text inside is paragraph 1. And find similar to find all, but with find it only return the first tag object that matches. And we also have find parent, iterate over all the parent and check each one against the provided filter to see if it matches. Find a sibling, iterate over the rest of an element sibling in the tree and return all the sibling that match. Or find previous sibling, iterate over an element's previous sibling in the tree and returns all the siblings that match. And we have another example. We create another soup object, and this is the HTML that pass into that soup object. So we have an other list of item, and so the first thing we do is we find a list item that whose text is find. So we have this one, we select this one, and then next from that one we find the siblings list, that the our list element and whose class name is tag, which is those. We skip this one and then we select those. As you can see, find and find all, find parent, find sibling, they can apply to a sub-object, which is this one. However, it can also apply to any tag object that you already selected. The difference is that it will not start to select at the, like, with the with applying on a sub object, it will start to search from the root of the document. However, when you apply to a tag object, it will um it will only apply to, it will start from that element that you applied. For example, here we have a container and then we use find all, and we'll start to find from this container element. So next we use what we learned about Beautiful Soup to web scraping a website from Center of Disease Control and Prevention website. So let's look at that website. So as you can see, we have a table down at the bottom, and so I want to web scrap this table, and so uh so in order to work with Beautiful Soup, we have to have the HTML document as I mentioned, and one of which that we can do is using request and using doc text to get the HTML source page of the page that we request. However, if you want to get select the table, you cannot do that. Why? This is because like request only be able to get the static source page. Meanwhile, the data that we have here is dynamic data, which means it is they JavaScript generated content. JavaScript generated content is that those data only loaded when our web page is fully rendered by the JavaScript. And using request we cannot get that data. So as you can see, we have those script tag. They contain the JavaScript code that help render the dynamic data that we have here. So we cannot use request. So the cool thing is that we can use a browser automation tool called Selenium driver. What it can do is that it can open your web browser. It can then if you specify the URL, it will go to that URL. It can also help us get the source page when our page already fully rendered by JavaScript code, so that we get all the HTML code for that contains our table. So we can, and also Selenium driver also can allow you to like mimic browser action, like clicking a button and so on. So let's install it. So we can use pip to install, and also when installing Selenium, you also need to install the some web drivers, Chrome, Firefox, Safari, Internet Explorer. And here we use Firefox driver. So if I run this code, the first thing it will do is that it will open the web browser, the Firefox web browser, and then it will get to this URL that I specify, and then it will wait for 10 seconds before doing anything. So you can see here we get a page already fully rendered by JavaScript code. And to get the page, to get the HTML source, we can use driver.pageSource. As you can see over here, that this cell soup3 equals to beautiful soup driver.pageSource. And once we have the soup, we have the access to the this HTML document. We can query, we can select element and get the data. So we can find a table. First, we can find the table element that has the class name, table content, and then from that table we can find all table row, and from those table row we iterate over each table row and we find all the div element contains the table data, and then we use tuple to contains all of the data in the row, and we store all rows data inside a list. So I have put this code inside of this method. Here we not only want to we we to select this table, we also want to select the table, next table, next table, and here we have 25,000 records, which means we may have 1,000 table. And I want to do that. However, using beautiful soup alone, we cannot do that. We only get the source page of the first table. So, but Selenium can help us to click to the next button, and then we can get the source page, and then we can use beautiful soup to get the content of the next table. So here, so putting all together, to obtain all data table, we have a loop whose each iteration needs to click the next button. So the driver that we have here can execute to click a button first, and then we can get the HTML source page using driver the page source, and then from that page source we can create a beautiful subject. You can see over this code, and when we have the subject, we can get the data, and we can use that data to extend our list. We store that list inside this Scrap data list, and once we have the data, we can create a data frame and pass in that data, and then we can export using data frame to CSV. And so next we can use our data for data analytics. I create a table, and this data, as I query, I know that it is the data COVID data for 56 counties in America, and it is collected on February, someday on March, and someday on April. So as you can see, like the COVID-19 dropped down over time, and I also plot another table. This table shows that most of the state the COVID-19 cases decrease over time. However, some cases um, I can like American Samoa or um, District of Columbia or New York, no, or New Jersey, New York, the number of cases increase. So next, we look at the second web scraping tool, which is the most popular one, which is Scrapy. Scrapy is much faster, and it allows us to send a request and get the HTML document. It allows us to define how we are going to extract the data, and it is faster because Scrapy schedule and process requests asynchronously, which means when a request is sent and process another request is also doing. And also like Scrapy also provide ways to write cleaner code. When you select element, it will write cleaner way to select, and also it also provide way to export data. um so we need to install Scrapy first of all, and the second thing we need to do is define a spider. So the so here in this project, I to demonstrate the infrastructure of Scrapy, our group uses an example created in the Scrapy tutorial webpage, and this webpage contains code, and also you can click next to go to the next code. And so first we need to define a spider. So what is spider? A spider is a class that you define, and Scrapy uses it to scrap the website. So it should be the subclass. It is a subclass of Scrapy.spider. And there are several things that you need to define within your spider class. You need to define the name of the spider, and different spider within the same project should have different name. And then you define the URLs to start with, and it can be a list of URLs. And internally inside this subclass, there is a method called star request, and this star request will send a request to the URL that we specify, and it will return a response, and that response later I will discuss later how to use that response to extract data. So the next thing we also need to define for this class is the custom setting, and this custom setting, one of the things that we need to set is how are we going to export data. So as you compare with the beautiful Scrapy provide us a way to export data. Um, Under the hood, it will help us to export the data. We only need to define which how are we going to export. So here we are going to export to a CSV file, and the format we also need to specify format and other setting keys that you can find inside of this link over here. And next, after define how are we going to export the data, we need to define the parse method. So as I mentioned in this, the star request returns response. So and after returns response, the Scrapy, the spider will call a callback function named parse, and this name parse would receive that response, and this response object would have the HTML document, and it would have the method that we can use to select element and to extract the text data within that element. So the two things that a parse function do is that it first it extracts the text content and it returns the data in the format of a dictionary. And as you can see, it uses a generator to return instead of return the list of all code. It just return a generator, and this generator will be used by the Scrapy spider to export the data to a CSV file. And the second thing we do is that we find a new URL, so to and then continue crawling to this URL and continue extract data. So this is the complete definition of the code spider, and you can run it used by creating a crawler process and start to crawl. So next we need to learn how to extract data from the response object. So how this would work, how this code would work. So Scrapy provide a shell that you can use to extract data using Scrapy package, and there's a link that I include in this one that has it is a tutorial show you how to use a Scrapy shell to learn to extract data using Scrapy. So we so Scrapy provide a cleaner way to select element. As I mentioned, we select using the CSS selector. For CSS selector, so response.css. So as you can see over here, we select element whose tag name equals to small. We select all those elements whose name whose tag names are small, and using get all to get all of those elements. And we also, if you only want to get the text inside the element, we attach double colon and text to our CSS selector. And also like we can also apply regex method to our list of elements as showing here. It will iterate over each of those elements, and it will apply this regex and extract this group, which is the last name of the author. So how are we going to create CSS selector? Sometimes we may only use the tag name, but sometimes the CSS selector become much more complicated to allow us to select the correct element. So inspector tool is our friend. So here we can using this one to click to select an element, and it will show us the HTML code for the element. So we want if I want to select this code, this block of code, I can use div. I can search using this search HTML element using this box. So div, and this div, I want to like identify it, distinguish it with other div through the class name of this div element, which is code. So that code, and when I click enter, as you can see, we're gonna click enter, it will go to this code, the next code. Enter, it will go to the next code. So within a code, I have a span contain the text of the code, and another span, and inside the span we have a small, and this small contains the name of the author. So if I want to get the author, I need to look at the span. So separate between element is the next trial. So we want to guess to the next trial, so we use the greater than sign and the span, and then we also go to another trial within the span, which is small, and as you can see it go to this item, and you click enter another same item, enter another same item. So you can use this inspector tool to get to learn to use to create a CSS selector, right? And so let's examine this parse. This parse, it will um this parse method, it will go through each code element using this CSS selector div.code. So it will select all the div element whose class name is code. So div.code, you can see it will select this code, this code. It will iterate all the code. In each code, it will go to, it will select the span, small, and get the text, which is the author name that I just showed you all, and it will go to the span.text. It will look at the span element whose class name is text, which is this one, this text. And to obtain the text, we use double colon text and that get as well. We also need to use that get to get the text. And the second part of this parse function is finding a new URL and go to that URL and send use that URL to send the next request and continue the extract process, extraction process. So it select this element list whose class name is next, go to the element and select the A tag. So let's look at the element list next. So look at the list item whose class name is next, and then look at the A tag, and which is this one. And what it gets is that it gets the attribute href, so it gets this link. It is going to get this link. So it will use this link and follow to that page and continue extract the data using our parse method. So to the next page and then get the next code. So this is how it works, and we can also next we use Scrapy to web scraping our COVID-19 data. So but Scrapy only send a request and get the static content. So we also need a browser tool that allow us to load the render the JavaScript using fully render the content that use JavaScript. We also need some browser automation tool, but as I came across an article, is that like Selenium may not be a good choice for web scraping project, and Splash is recommended. This is because Selenium is a full feature browser working in the background and consuming a lot of system resource. Sometimes it may slow down your program. So Splash is recommended because it is a lightweight browser that allow us to render JS content. And And very fortunately that Scrapy also integrate with Splash. So need for so when we use Scrapy, normally we don't use it with Jupyter Notebook. We need to create a project, and inside the project we have the Python file. So the first thing we do is creating a virtual environment. When working with Python project, we are recommended to create a virtual environment because different project may require different version of the same module, and to avoid conflict between different projects, we can create a virtual environment, and in that environment we install our Scrapy, uh, and then install Scrapy Splash, and then create a project using this command Scrapy start project, and it will create all of the file. It will create a folder contains all file that we need for our Scrapy project. And inside the project there is a file called setting.py, and we need to put those setting inside that setting.py file to allow the splash to work. And we also need to install Docker, and inside a command prompt we run this code, and after running this code, Splash will be available at port 8050. Um, so and also inside of our Scrapy project folder, there is a spider folder that contains the init.py file, and inside the init.py file, we put our spider definition. So the spider definition now looks a little bit different. We need to override the star request because here we don't use the normal request. We use the splash request that allow us to render the JS content and get the fully rendered HTML document. And this callback function, this splash request constructor receive the URL, the callback function that we will use to define how we're going to extract the data, and this endpoint define which content in our response we are going to get. We are going to get an HTML document. So, and we also like using CS selector to select the content, and Splash also can allow us to click on a button and get the HTML content of that the page that we are at after clicking the button, and we can continue to swapping with another table in our web page. So as you can see, Scrapy provide us an integration with Splash that allow us to read dynamic content. It also provide much simpler way to extract data using CSS selector. It provide export feature, allow us to export to CSV or JSON or any CSV or JSON, and provide us a much simpler interface to work with uh, web scraping data. And so this is the end of the recording. Thank you for listening.